Today we're going to talk about electron configurations. Electron configurations are when you explain where each and every electron is around an atom. There are two ways to do this. I prefer the second way, but I'm going to show you the little shortcut that some people use, and it looks like this. Electrons are arranged in the shell that they occupy in electron clouds, and these clouds come in four types: an S sublevel, a P sublevel, a D sublevel, and an F sublevel. An S can hold up to 2 electrons, a P can hold up to 6, a D can hold up to 10, and an F can hold up to 14. The way you use this diagonal diagram to come up with electron configurations is, for example, let's do iron. And if we look at iron on our periodic table, we can see right here it's atomic number 26. That means it has 26 electrons. And we need to account for the location of each of those 26 electrons. So we start at the top of our diagram, and the first two are going to go into the 1s orbital, and it can hold a maximum of 2, so we're going to fill it up. Then we go to our next diagonal, and our next 2 electrons are going to go into the 2s, and being an S, it can hold up to 2 maximum. Now we go to our third diagonal, and our next electrons will go into our 2p. It can hold up to 6. So far we've placed 10 electrons. Notice the number of electrons is shown as a superscript for each sublevel. After the 2p, it goes into the 3s. It can hold up to 2, so that's 12 electrons. Going to the next diagonal, 3s has been filled, so we're going into the 3p. It can hold up to 6. Then we go to the 4s. It can hold up to 2. And next we're going to go to the 3d. However, it can hold up to 10, but we don't need 10. We only need 6 more electrons because we've accounted for 20 of them. We need 26. So in our D, even though it can hold 10, it is only going to have 6 in it. So that's how you would use the diagonal diagram. And the reason this is helpful is because you can start to see, you get these overlaps where a 4s fills before a 3d, and then a 4p, and then a 5s fills before a 4d. And so this is the diagonal diagram, and it shows you the order that the orbitals fill. Let's do one more using this method. So for this one, let's do barium. Barium is much larger. Barium's way down here, and it has 56 electrons that we need to place. So we're going to start out the same way. 1s takes 2, 2s takes 2, 2p takes 6, then 3s takes 2, then 3p takes 6, then 4s takes 2. Now 3d fills, that's 10. Then our 4p can hold up to 6. And then our 5s, s holds always 2. Notice all the s's have 2. Then after our 5s, we start at the top of the next one. We have 4d, it can hold 10. 5p can hold 6. 6s can hold 2, and that is 56. If we add up all of our little numbers up here, we've got to 56. So that is the electron configuration for barium. While it can be a great temptation to use that diagonal diagram, what you're actually doing is you're showing where all the electrons in an element go, and the periodic table shows you exactly the same thing. If we look at this periodic table, we can see it's broken down into an orange, a purple, a green, and a yellow section. The orange, and notice helium is an orange, you got to kind of think about it over here. The orange is where you have an S sublevel filling. If you're on the first row, that's 1s. If you're on the second row, that's 2s. If you're on the third row, that's 3s, etc. So that number in front tells you what row you're on. The green area is called the P block, and this is where our P sublevel is filling. Notice our S only had 2 columns because it can only hold 2 electrons. Our P block has 6 columns because it can hold 6 electrons. This purple area is our D block. It's where a D sublevel is filling. And notice that there's 10 of those because you can fit 10 electrons into a D. And then our yellow down here at the bottom, this is our F sublevel, and an F can hold up to 14, so there's 14 going across here. So using the periodic table, let's say we're doing something like platinum right here, 78 electrons. So its location is right here. And so we need to fill up all the electrons all the way to this location. So we're going to start up here. We have to fill in our first row. And we know our first row is going to be 1. It's in the S block, and an S can hold 2 electrons. And now our first row is full. So we go down to our second row. Again, we're in the S block, but now we're on row 2. So row 2, S block, fill it up with 2 electrons. Now we go across, follow the atomic numbers, 3, 4, 5. Now we're in a P block, but we're still on the second row. So this is going to be a 2P, and P can hold up to 1, 2, 3, 4, 5, 6. Now we're at the edge of our second row, so we have to go down to our third period, or our third row. So we are 3, row 3, we're in the S block, and we fill that up with 2 electrons. Now we follow this across, and we end up here. This is our still third row, P block, and we can fit 6 electrons into that. Then we go to our fourth row. Our fourth row starts with an S. Every row starts with an S. So we're going to fill up the S first. And now we enter this purple block. Now the D block is tricky. It is 1 level less than the row you're on. So we're on row 4, but this is our 3D. So just remember, these are always 1 less than the row you're on. And we're going to fill this all the way up so it can hold 10. Then we get to this green part right here. We're on row 4. We're in a P block, and we're going to fill it up. Notice the S and the P are the same as the row you're on. The D is 1 less, so the D is 3D instead of 4D. So we reach the edge of our fourth row. We go to our fifth row. So we're starting our fifth row. It starts with an S right here, and we fill it up. Now we hit this D, and we're going to fill that up. But remember, we're on the 5th row, so this is the 4D. D. We fill it up with 10, and then we hit the 5P, and it has 6, and we've reached the edge of row 5. We go down to row 6, starts with an S, fill it up. Now something happens here on our 6th row. If we look here, see this little orange block? That's where this block fits, right into that spot. So after we fill up our 6S, we have to jump down here and fill up this F block. Now, this first row of F is a 4F. That's the first sub-level, or that's the first level that has an F block. So notice, while the S matches the row it's on, 6, the F is back 2. It's a 4F. The D is back 1. It's a 5D. P is the same as the row it's on. So S and P are going to be 6, but 4F and 5D in between there. So we have our 6S filled. Now we need to fill this F block, and it's back 2. So we're on row 6, but it's a 4F. It's going to fill up with 14 across here, and that takes us to lanthanum right here. Now we're going to platinum, which is over here. So we are in our 5D, but we don't need to fill it up with 10. That would take us all the way to mercury. We only want to go to platinum, so we just need 1, 2, 3, 4, 5, 6, 7, 8 electrons in our 5D. Let's try another giant one. Let's try bismuth. It is atomic number 83. So we need to fill up row 1. We need to fill up row 2. 2 has an S and a P. Fill up row 3. It has an S and a P. So 3S, 3P. Now when we get to 4, remember 4 goes S, D, P. So 4S, 3D, 4P. That's reached the edge of 4. Now we go down to row 5. We have a 5S. Then we have to go to 4D, fill it up. That gets us to 5P, and we want to fill that up as well, because remember, we're going down here to bismuth, which is 1, 2, 3, 4, 5, 6, row 6. So we've got our 5P right here. Next we go to 6S. Then remember this orange part, we jump down here, fill up that top row, which is a 4F. It's 2 less than the S, and it can hold 14. That will take us to lanthanum. We want to fill up this 5D right here. It can hold 10. That takes us to the P. Remember, we're on row 6, so it's a 6P. And we need 1, 2, 3 spots over to get to bismuth. And that's how you do it using the periodic table. So the periodic table is a great tool. It is organized based on electron configurations with our S, our D, our P, and our F blocks. I hope this helped. Come back and join me for more videos, and have a great day.